Brilliant. Looks like we're kicked off. Give it one more minute for those that are joining to make sure they're in. Okay, fantastic. Let's get going. I'm going to share my screen. Great. Hello, everybody. Thank you very much for coming along. My name's Nick Law. I'm with JBA Consulting, and this is the first in a series of webinars we are doing on managing the risks of weather and climate in offshore wind using our proprietary tool called ForeCoast Marine. So during the webinar, my colleague Laurie will be answering any questions, so please feel free to ask questions in the chat, and we'll answer them. Laurie will answer them as we go, and if there's any at the end, I'll answer those too. So thank you very much for joining us. This webinar is called Early Stage Construction Strategies. So essentially, we're going to have a look at a theoretical project and have a look at how you can simulate projects at a high level for a very early stage assessment of project cost and project duration using ForeCoast Marine. And as this is our first webinar, we're also going to do a little bit of an introduction to JBA Consulting as well. But our series of webinars, we're going to cover some really interesting topics over the coming months. They will include how to model floating wind strategies. We'll be looking at simulating cable installations. I've heard from a few companies that can be quite tricky, so we'll be looking at that. We'll also be looking at how you can use climate change data in ForeCoast Marine to assess the risks of climate change to operations and maintenance, and also looking at some of the results, the verification results we've done from ForeCoast Marine outputs. But importantly, we're actually really interested to hear from yourselves. If there's any topics you want us to cover, then please do let us know, and we'll endeavour to put them in our programme in the coming months. But to kick off, a little introduction to JBA Consulting. We are a UK company. We're an independent weather and climate risk management consultancy. So we're all about mitigating the risks around weather and climate in our changing environment. And I sit in JBA Consulting. JBA has grown into a family, a group of companies over the last couple of decades, and they include our colleagues in JBA Risk Management. They are experts, in fact world leaders, in catastrophe modelling, flood modelling and flood mapping on a global scale. We have our colleagues in JBP or Jeremy Bend Pacific, who are experts in scientists and engineers and experts in extreme weather engineering. And we also have our own charity called JBA Trust, whose mission is to increase awareness and resilience to through outreach and research and education. So that's the JBA group of companies. We have over 700, probably closer to 800 employees now, spread around the world. We have offices from the US through UK and Europe out to Singapore and Australia. Now, over the last 8 or 10 years, we've been working to support the offshore wind sector, particularly around managing and mitigating the risks of weather and climate. And we've worked with a variety of companies. You can see a selection of them here, including big global developers, tier 1 suppliers, engineering companies, vessel operators, and other key stakeholders in the offshore wind sector. We've done this using our own in-house software called ForeCoast Marine, and that's what we're going to be looking at today. And ForeCoast Marine is comprised of 2 main parts. The first part is this, what we call the design desk. And this is the strategic planning software where clients or we can simulate and optimize projects for transport and installation or operations and maintenance with a view to calculating the project duration and downtime, and costs, and optimizing them to reduce those. It also has a part, the other part of the software is called the control desk, and this is more about the day-to-day management of wind farms, and it includes a suite of tools for that, including a very detailed weather windows tool for planning your operations in the coming days and hours. It has the ability to track progress and test solutions if your progress veers off target, and also a route optimization for surface and subsurface vessels. We'll probably look at some of the control desk capabilities in future webinars. But for today, we can use ForeCoast Marine on a theoretical wind farm up here on the northeast coast of Scotland, and we'll be using it to do a high-level, very early stage assessment of cost and downtime for different strategies. So we'll be looking at 4 strategies today, so 2 different port strategies, and we've got our 2 ports here, Wick and Very North and Nig, and we'll be comparing also 2 different vessel strategies. So one strategy simply with 2 jack-up barges, and as a comparison, we'll use 2 jack-up barges with a reduced operating capacity. So we've simply gone in and reduced the operating limits of wind height, wind speed and wave height by 30%, and also the cost by 30%, just to see how it compares once you use those in a project and simulate it. So that's what we'll be doing. So we'll have 4 simulations in total. I'll walk you through as if we're just doing one of them, and then we'll have a look at some results and compare, in brief, compare the outputs and see what kind of differences we can see with those different strategies. So I'm going to hop over now to our software. Just share my screen again. There we go. Hopefully you can see now. Please let me know if there's any problems seeing anything. So you should now see the home screen to our online software called ForeCoast Marine. Now, we've developed this over the last 8 or 9 years. We've recently, in the last 12 to 18 months, been building the user interface and putting through many features that people have been asking for. And this is the homepage. It's hosted on AWS, and this is my project page. So you can see I've got 4 projects in here, and today we'll be having a look at this early stage construction. And I'm going to walk you through as if we were building a simulation, and then have a look at some of the outputs. So within our project here, to start a project, you input some basic details. So let's have a look at our project detail page. So the kind of project details we'll be uploading to start with include just basic information, which is essentially your project name, description, currency, etc. Then you will be uploading your assets. Now you can see our assets here. We've got 100 wind turbines in a square layout up here. You can upload your assets a couple of ways. You can use upload a shapefile of locations, as we have here, or you can use our generator tool to actually plot your own grid of assets to work with. But we'll go with the 100 turbine layout that we've added here. After your assets, you can add as many ports as you like. As I mentioned, we've got 2 ports here. So you simply add your ports, and the ports are defined by the name and the location. We've got Wig, Nig and Wick. If you want to add more, you can here. Just go back. And then finally, in our project setup stage, we'll be looking to add some metocean data. Now, we've uploaded for this project a CSV file from the ERA 5 database. So this is giving us about 31 years of hourly metocean time series data to work with. You can add as many metocean data points as you like, and we're actually, there's a couple of developments happening at the moment. We'll be including a database of ERA 5 in our software in the coming month or two, and we're also actually exploring the use of ultra high spatial resolution data, even up to or down to 30-meter resolution for particularly challenging coastal areas. So that's where you upload your metocean data, and that takes us to completion on the basic project details. So now we can move on to actually setting up a simulation. So if we go into our simulations page, we've got a choice here of a construction simulation or O&M. Today we'll be looking at some high-level construction simulations. And you can see the 4 strategies that I mentioned, we have preloaded already, or made them in here. What we're going to do is run through one of them as if we're actually setting it up. And very straightforward, and then we'll show you how you can clone the simulation to do what we've done here and just change some of the particular elements in it. So if you want to change a strategy slightly, it's very easy to do so. So let's, for the purposes of today, let's have a look at the standard spec vessel using NIG as the port. So we'll go into here. Now, you go through, to set up your simulation, you go through a series of setup steps using these green cards. They're green because I've already gone in and put the data in. They would be, if this was setting up a simulation from scratch, they would be red, and they would turn green as you enter enough data for the simulation to run. So we'll take a look through at these one at a time. So firstly, basic project information is, as it sounds, just the name of your simulation. In this case, it's the standard spec vessel for NIG, and it's a construction simulation. Then we would select our metocean data, and as I mentioned, you could have as many in here as you liked. If it was, for example, a significant distance from the shore, you might have several metocean data points, and at this stage you would choose which one you want to simulate with. And then we will move on to our settings page. So what you do in settings is set how the simulator is going to run. So essentially, we've got data from 1990, so 31 years of data. Let's say our project is going to take an expected 6 months. You can set this to run at the beginning of every month from the 1st of January 1990. And then it'll run once, then it'll run again at 1st of February 1990, 1st of March 1990, etc. So you'll end up with 350 simulations to use as the basis for your statistical analysis. If you want to run the simulation every week over that period, you can do that. And if you want thousands of outputs, you can set it to run every day. Another option here, which can be quite useful, is to set the model run duration. So if you were interested to see how many assets you could install in a fixed period, say how many foundations can we install in 2 months, you could set your model run duration to 2 months and calculate that. So that's where you set your simulation. Once you've done that, you can move on to select which ports you want to use. We're looking at NIG, so there's 2 potential ports we've uploaded here. Again, at the start on your project page, you can upload input as many as you like. For the purposes of this, we're going to be using NIG. So we'll select NIG and leave WIC blank. And then we can move on to our assets and bringing a bit more detail into our assets. So the project phase, we simply defined the layout and the type of asset being wind turbines. And here's our group that we've created of wind turbines with our 100 assets. Now we can start to bring in, build those assets in more detail. And we can do that by editing the properties. I don't want to edit the layout at this stage, so I'll go back and edit the properties. So the properties are defined by the components that it's made up from, and the hub height that will be, if you need to simulate at hub height. So for the purposes of this, we're just doing things at a very high level, so we're not having a huge amount of components. If you want to add, you can add as many components as you like. We have a library of pre-defined components, as you can see here, from anchors to floating platforms, inter-array cables, etc. Or you can use your own defined components. So there's no limit to how much detail you can get to here, or you can keep it nice and high level for a very early stage assessment like we're doing today. So we'll be working with these two components, pile and transition piece, and you can set the order here that they are to be installed in. And this is simply drag and drop to change the order. We'll go with pile and transition piece in the correct order. So we've done our assets, our ports. Now we move on to defining our vessel groups. So we click on edit vessels. And like the assets, we work with groups of vessels, and a group of vessels are vessels that have the same operating capabilities. So for this, we only need one set of one vessel group, which is jack-up barge. We're going to use 2 of those for our strategy. And the properties that we're defining for those vessels include the transit speed of 12 knots, a relocation speed of 8 knots. It's not an installation vessel, so we don't need to define that. And the daily rates. So we have on our standard spec vessel, we have $180,000 per day to work with. So we can simply save our vessel characteristics here. Now we move on to transit routes. So transit routes, another area where you can be as complex or as simple as you like. For our NIG installation strategy, there's not much complexity to this. We've got simply coming through the Firth and Cromarty, we've got 1-2 waypoints, and then it's straight out to our site. But you set the waypoints here, which is a very easy process of putting in your coordinates, and then you can either replicate your return journey to be the same, or create a different return routing if necessary. So that's our transit route set. Now we move on to the work packages, where we'll get into a bit more detail about what we're actually trying to install. So we can work with different types of work packages. We've got pre-assembly work packages, which could be for assembling components on at the port. Post-installation work packages, which could be commissioning. But today we want a simple one work package strategy. You can have as many work packages as you like, and you can set them to be completed in sequence or operating at the same time. Today we've got one work package which we're going to call installing foundations. And what we do is go through each of the tabs here to choose which elements we want to include in this particular work package. So it's a very quick process of selecting the assets. So if we wanted to have 2, 3 or 4 work packages to install the turbines, we could do. For the sake of this, we'll install all of the turbines, but if you wanted to just install a selection of them for each work package, you can do that. We're just going to keep it simple here. Choose which components you want to install in the work package. We'll choose both of those, the pile and the transition piece. And then you can set your schedule. If you had multiple work packages, does one need to have a delay before the after the first one's completed? Is there a delay before the next work package can start? We'll choose our ports. We've only got one port, so we can go with NIG today. And transit routes, again, very straightforward. Just click on select outbound and return routing. Right, now on to installation vessels. So we know we've only got 2 jack-up barges to work with. You can have as many vessels as you like. You can add different vessel groups. We've just using the one group here. And the vessel groups, the installation vessels are where you really set the detail about the individual operations and the weather sensitivities around that. So the way it works is the work packages broken down into activities. And here we have our 7 activities, which start with loading out foundations, transiting to first asset, transiting to first asset, installing, relocating to next asset, etc. The logic flow in the simulation follows this logic here. So starting loading out components, transiting to site, transiting to first asset, first installation. If the installation vessel can then continue to install, it goes to the next asset and follows this cycle here. If it needs to then return to port to load out again, then it goes back and does that. So that's the kind of logic we'll follow. And the process for setting the individual operations within the activity is done by clicking edit here. You can see on the poster for each one, you've got the basic details that we've set. So is it suspendable? If it's suspendable, it means the operation can start if there is a bit of weather downtime expected. If it's not suspendable, the simulator will wait for a weather window that's long enough to complete the entire activity. And in this activity, we have 11 operations, so we can have a look at those now. So this is another area where you have the choice to be very light on detail or get into for very early assessments with lots of assumptions, or you can get into an immense amount of detail here for late stage engineering design. So in this case, we've broken the activity down into 11 operations. Again, drag and drop for the order that they are to be simulated in. Jacking up, for example, we've allowed 4 hours with a 6-hour starting window, so a factor of multiply of 1.5. You can set that to any weather window duration you like, and a summary of the weather thresholds that this operation can happen in. So if you want to edit this, you go in here. So this is our operation of jacking up. We've got 2 weather thresholds set for this operation. We've got a significant wave height of 2.5, maximum of 2.5, and a maximum wind speed of 14 meters per second. You can add as many weather variables here as you like. So if you have a particularly sensitive operation, or an operation that can only have, let's say, we have about 18 different metocean parameters you can work with. For example, if your vessel can only operate when the current direction is from the northwest, you can set that. And if it can only operate if there's a peak wave period of less than, let's say, 5 meters per second, then you can set that here. You can get into as much detail as you want, and you can have individual weather thresholds or grouped weather thresholds. We'll select the components that we want to install for this operation, and if there's any time restrictions. You also have the opportunity here to specify if you want this particular operation to use a different metocean data set. It will, as standard, use the closest one, but you can set that to use any metocean data set that you require. So that's you follow the same process for all of the different operations within the activity. As consultants, we can help with this. This is, you know, the quality. If you want to do a detailed assessment, the quality of this is really, you know, good quality in, good quality out. And as consultants, we can help with this process as well. We've been doing this for many, many years. So once you've gone through the process of adding all your operations, you're really, you've done all the hard work. And then you can, there's one last thing you can choose here before you move on to simulating. You can set your statistics if you want to work with a particular p-value or percentile, mean or max, etc. You can set those here. We've got them set to the standard 50th percentile and 10 and 90th percentile. So at this point, you've done the hard work. You can check your dependencies, so it'll go through all of the different required inputs, checking that it's got what it needs to run a simulation, and then you simply run your simulation from here. Now, we've done those already. Typically, it takes a few minutes to run a simulation. You can see that these ones have completed. If you wanted, what I haven't shown you yet is if you wanted to, at any point, whether we're dealing with a simulation here, a work package, an activity, or even an individual operation, you can clone your work at any stage. So, for example, here, if we wanted another strategy, maybe another port or a different type of vessel or a different number of vessels, then you can simply clone your simulation or work package or activity, and that's already done that here. And then you simply go and change some of your parameters, and hey presto, you've got another set of outputs to compare. We don't need that today, so we can just go in and have a look at some of the outputs. So simply click on View Results. So as you can imagine, there's a huge amount of data produced in running these simulations. There's tens of thousands of outputs. So there's different options about how you can manage that data. So first of all, you can use the drop downs here to select if you want to view some of the plots. We'll just have a look at a couple of these options here. So if we simply look at campaign duration monthly, this chart will show us, if you can see that clearly, hopefully, this is the total duration simulated if you started on each month of the year. So if you started on a January, the 50th percent outcomes show that, or 50th percentile show that the total project duration is approximately 140 days, whereas if you started in June, you're looking at about 98 days. the grey box, the whiskers, show the total range of outcomes from all of your 350 simulations in this case. In a similar fashion, you can look at finance from the different elements of the project. You can look at different vessels, different activities, etc. This is a very high-level project, so we can just look at the cost of the let's say vessel cost for monthly, similar profile to, as you can imagine, to the duration if you would start in January. We've got a total vessel cost of $50 million, whereas if you were to start in June, you'll be looking at closer to $35 million. So that's the charts. Like I said, there's access to a lot of charts depending on what you've actually included in your simulation. You can view the statistics again in a similar way with the drop-down menus, and then filter your results here. And you also have the option to download all of your statistics. And I'll show you, I've pulled out some of them already, and I'll show you some examples of the kind of things you can download. But you can download all of the statistics as a CSV file, all of the plots, and the activity schedule. So I'll switch screens and have a look at that for you now. So I'm just going to go back in and share here. So these are some of the points that I wanted to highlight for you from the results section. So first of all, this is a screenshot of the file that I've downloaded, the CSV file with all the results in. Very easy to, I filtered here by the variable resource duration, so you can see the results from that, and likewise I've then ordered them here by the variable, the downtime variable. So showing you, highlighting where the downtime is and what kind of downtime identifier it has, whether it's logistical downtime, whether it's weather downtime, etc. So likewise, you can download all the plots. There's a wide variety of plots to download, and some of those I'll show you in a second. Just wanted to show you the activity schedule you can download. So this is an hourly step-by-step spreadsheet of all of the activities and operations that have happened hour by hour, and again what the contributing downtime factors were. You can download pie charts. This one shows the total downtime for activity and operations. In this case, we have, you can clearly see you've got your biggest contributor to overall downtime is within the activity installing foundations, and the operation was the pile driving, followed closely behind by loading out foundations, particularly monopile 1. And then the other section in the pie chart is any contributor that's below 5%. And if you want to go and interrogate that in the data, that's very easy to do. You can also download the cumulative distribution function, so you can assess the costs and durations, etc., depending on your risk appetite. So, for example, here it's very easy to see there is an 80% chance that your costs will be lower than $56 million, but there is a 60% chance they will be lower than $50 million. So you've got that full range of probabilities to work through if you need to. And finally, I thought it'd just be interesting to have a look at the 4 different strategies that we have simulated in this project side by side, so we can see some of the scale of the differences essentially. So here's our chart showing campaign duration. I have to say I was quite surprised by the difference in duration when you consider you've got a 30% difference in operating capability just in wave height and wind speed. In the summer months, you've got well over twice the duration from the less capable vessels, which I've found very interesting, and also particularly the fact that that's more prevalent in summer. In winter, there's still a big difference in duration, but it's not as pronounced in the summer months. You can also see, as you would expect, NIG being further away, taking a slightly longer duration than WIC. And again, that's a bit more pronounced over the summer months, but not significantly. Cost-wise, follows a similar profile, although probably not as pronounced as the project duration. But again, you're looking at the 4 different strategies here: NIG higher spec vessel in orange and WIC higher spec vessel in blue. You're looking summer months cost of $30 to $35 million for the entire project cost, versus close to 60 million in July. 60 million in June. Biggest difference really July. You've got project costs of low 30 million up here to 70 million, which is fantastic. And that's what this software is all about. It's being able to simulate projects from an early stage and looking at the cost and the downtime and the duration of different strategies, and the kind of figures you're talking here are huge sums of money. So it's amazing to be able to very easily replicate those in a very reliable way and see this level of difference. Finally, this is all of the values together. So the previous one was split out by month. Again, just to highlight some of the difference in campaign duration you can have between your best strategy and your worst strategy. So you're looking at 120-day versus 240-day, huge difference. And likewise, vessel cost, your overall project cost, you're looking from 42 million up to 62 million as an average between the best strategy and the worst strategy. So this is the kind of thing the software does. We've been using this software for many years, and it's proved itself in projects around the world. We're still doing it. We're consultants. We're experts in managing weather risk in industry. We're still doing this, and we're working on projects around the UK at the moment, in Japan, Taiwan, South Korea. We now have the user interface, so clients can do this directly themselves, but we are still here to work as consultants and support on projects. And we're in a unique position, as I mentioned, to offer the licensing of the software, delivering this service as reports, or somewhere in between. And we actually offer, as part of our license, we actually offer 1 hour a week as standard consultancy to support on projects, whether it's to provide assistance, sense checking, general project support. That's actually included in a license. And that brings us to the end. Laurie's been answering questions. Thank you very much, Laurie. I haven't had any questions come in the last few minutes, so I'd just like to say a massive thank you for coming along. I hope it's been interesting. Please keep an eye out. We're going to be looking at some really interesting topics through the eyes of ForeCoast Marine. If you want us to address something specific, please do contact us, and look forward to seeing you again. Thank you. Bye-bye.